Welcome to Things You Don't Know. Today, we're looking at something that changed almost beyond recognition within a single lifetime: the television receiver itself. Not television programs, not networks, and not the history of how programs were delivered into our homes. No, we're going to cover those subjects in a later episode. Today, we're interested in the machine, the box, the picture tube, the controls, the screen, and eventually the computer that we now call a television.
And we should begin by correcting a common misconception. There really wasn't one inventor who suddenly invented what we call television. The modern television receiver emerged from a long series of inventions involving mechanical scanning, vacuum tubes, electronics, color systems, transistors, digital circuitry, and new types of displays.
Which means when somebody asks, "Oh, who invented the television?" the most accurate short answer is probably, "Oh, how much time do you have?"
The basic problem was deceptively simple. How do you take a visual image, break it into pieces, transfer information about those pieces, and reconstruct the image somewhere else? In 1884, German inventor Paul Nipkow patented a rotating disc containing a spiral arrangement of holes. As the disc rotated, the holes could scan successive portions of an image. Nipkow never produced a television set we would recognize, but the scanning principle became important in early television experiments.
So early television didn't begin with a screen. It began with the idea that you could dismantle a picture into information and then put it back together again.
Okay. For most people, thinking about that, what you just said doesn't make sense. We're going to try and unravel that thread for you folks. Well, what Chandler says is exactly correct. The basic concept survives today. Modern televisions do it electronically and digitally rather than with a spinning metal disc, which is how they did it in the first place. But television still depends on breaking images into very small components and reconstructing them rapidly enough that we perceive continuous motion. It's fascinating. During the 1920s, inventors began turning the scanning idea into working television systems. John Baird in Britain became one of the best known pioneers of mechanical television, while Charles Jenkins conducted some important experiments in the United States. The resulting receivers could be surprisingly crude by modern standards, to say the least.
In Washington, D.C., the Smithsonian has a Jenkins radio visor designed to reproduce only 60 scanning lines. Another Jenkins receiver operated with just 48 lines and about 15 pictures per second. Compare that with the millions of individual picture elements displayed by a modern high definition television.
And we're not talking about something that you would confuse with a movie theater.
Not remotely. The images were small, very low in detail, and often difficult to watch, but they demonstrated that moving pictures actually be reconstructed in the home.
Let's see. So, mechanical television worked. The problem was that it didn't work well enough. Increasing picture quality required increasingly difficult mechanical scanning. Electronics offered a much better solution.
Yes, they do, Dr. Weaver, and this is where the names Philo Farnsworth and Vladimir Zworykin usually enter the story.
Yeah, Farnsworth developed his electronic television system in the 1920s. In 1927, he produced an electronic camera tube he called the image dissector, which converted an optical image into an electrical signal.
Meanwhile, Vladimir Zworykin worked extensively on electronic television technology. eventually becoming a major figure in RCA's development program. It's important we should resist turning this into a simple Farnsworth versus Zworykin story. Television emerged from numerous researchers in competing laboratories over decades.
But the crucial change was that the spinning disk was disappearing.
The receiving end increasingly depended on the cathode ray tube, or the CRT. The device generations of viewers eventually knew simply as the picture tube. Inside that large vacuum tube, an electron beam was directed across a phosphorescent screen. The beam scanned across the surface in a repeating pattern, producing the visible picture.
And that technology would prove remarkably durable. Once the CRT television became established, the basic picture tube design dominated home television for roughly half a century. The transition toward reliable electronic television was well underway by the time RCA publicly demonstrated television at the 1939 World's Fair.
Now, when we look at early television sets today, one thing seems quite strange. The cabinet can be enormous, but the screen is quite tiny. What's up with that, Dr. Dineen?
Well, Chandler, the screen was only one component among many. The cabinet contained transformers, vacuum tubes, tuning equipment, power supplies, multiple speakers, and the picture tube itself. And picture tubes presented another problem. If manufacturers wanted a larger screen, they generally needed a physically larger tube extending further behind it.
Which is why television became deep as well as wide. By the late 1940s, television receivers were increasingly being manufactured for consumers. One surviving example in the Smithsonian collection is RCA's 630TS receiver, associated with the early post-war television era.
And these weren't just lightweight electronics. Some televisions were pieces of furniture at this time.
Very deliberately, manufacturers put them in wooden cabinets designed to fit into the living room alongside phonographs, radios, tables, and other furnishings. Eventually, the cabinet sometimes became almost more impressive than the screen.
Yeah, it's worth explaining what viewers were actually looking at. The inside surface of a black and white CRT screen was coated with phosphor. An electron beam swept rapidly across the screen. Changes in the beam's intensity produced lighter and darker portions of the image.
So there wasn't really a little picture sitting inside the television, was there, Dr. Weaver?
No, not at all. The receiver was continuously rebuilding it. And that explains something older viewers will remember. Televisions sometimes required adjustments for vertical hold, horizontal hold, brightness, contrast, and fine tuning. When synchronization failed, the picture might roll, tear, distort, or drift.
Modern viewers are accustomed to just switching on a screen and assuming the geometry will be perfect. Earlier television required considerably more cooperation from the owner.
Yeah, including walking across the room to change channels.
Yeah, now at this point in our history, we haven't quite solved that problem yet.
Then things
Not yet.
become then things become more complicated. Black and white televisions were complicated enough. Color created another major engineering problem. A successful color system had to reproduce red, green, and blue information accurately. And in the United States, there was an enormous practical issue. Millions of people were eventually going to own black and white sets. A color system that made all those existing receivers useless would be extremely unpopular and difficult to introduce.
Yeah, different approaches competed. Eventually, the FCC approved the compatible RCA developed color system with color broadcasting under the new standard beginning in 1954. Black and white receivers could still display the programs in monochrome.
And I have to say, that compatibility may be one of the most important parts of the story here. People didn't have to throw out their televisions simply because someone else brought in a color set.
You're exactly right, Chandler. Technological progress often succeeds not merely because the new technology is better, but because engineers figure out how to introduce it without making everything else that's already in use instantly obsolete.
Yeah, color CRT receivers were considerably more complicated than black and white sets. Instead of simply controlling brightness, they had to produce correctly aligned color information. Early color sets could require careful adjustment, and for years, color set television sets remained relatively expensive.
Now, there was another television invention that may have done almost as much for family life as color TV.
The problem solved. You don't have to walk across the room.
Yeah, the remote control television. Dun, da, da, da.
Early remote systems appeared during the late 1950s. Zenith became especially associated with wireless television remotes, including its famous Space Command system. I saw one of those. It looks like something from Star Trek. The Smithsonian Museum preserves a Zenith Space Command 200 remote and its matching television equipment in my favorite place on earth, the National Museum of American History in Washington, D.C.
Yeah, these weren't originally infrared remotes like the ones that later became familiar. Some systems used ultrasonic signals. At roughly the same time, another revolution was occurring inside the television, the transistor.
Ah, which meant fewer vacuum tubes, right, Dr. Weaver?
Eventually, yeah, for sure. Vacuum tubes, they generated heat, consumed considerably more power, and they could fail. Solid state electronics allowed circuitry to become smaller, more efficient, and more reliable. The Smithsonian has a 1958 experimental television receiver built at Texas Instruments using semiconductors rather than conventional tubes. An early indication of where television electronics were really heading.
But television evolved in a somewhat strange direction during the 1960s and 1970s. The electronics were becoming more sophisticated, yet many televisions were still enormous.
Oh, the console television.
You're exactly right, Chandler. Large wooden cabinets sat directly on the floor. Some combined a television with a radio, stereo equipment, and tape recorders. Manufacturers treated electronics as furniture.
And there was a physical reason the television remained deep, the CRT. A large conventional picture tube needed substantial depth behind the screen. Increasing screen size therefore meant increasing the size and weight of a large glass vacuum tube.
Yeah, which explains those old televisions that required two people, three people, or possibly a small construction crew in order to move that big old thing.
Yep, and unlike modern flat screens, there was no convenient way to hang a large CRT television on the wall. The wall probably couldn't have done anything wrong enough to deserve it.
Ladies and gentlemen, we'll count that as a one questionable joke for this episode.
I agree, Dr. Dineen. Now, at the same time, televisions were also getting smaller.
Yes, solid state components made genuinely portable television practical. Small televisions appeared in kitchens, bedrooms, dormitories, campers, and eventually automobiles, even. Yeah, there were even tiny battery powered televisions with miniature CRT screens.
Dr. Weaver, this created an interesting split in television design. Manufacturers were simultaneously producing enormous living room consoles and increasingly compact portable sets.
But Dr. Dineen both still relied on essentially the same basic display technology, the cathode ray tube.
And that became the industry's great limitation. Electronics could keep shrinking. The picture tube couldn't shrink if consumers wanted the picture itself to get larger. Something, something eventually had to replace it.
It took a while, and engineers experimented with several alternatives. Rear projection televisions allowed extremely large images, but usually required substantial cabinet depth and could suffer from limited viewing angles. Plasma displays, very expensive at the time, offered large, genuinely flat screens. Liquid crystal displays, LCDs, followed another path, using liquid crystals to control the light rather than firing an electron beam through the giant glass vacuum tube.
And suddenly, the television stopped growing backward.
That's a really good way to put it. For decades, a larger screen normally meant a deeper and heavier television. Flat panel technology broke that relationship. During the 2000s, plasma and especially LCD televisions rapidly displaced CRT sets. The CRT technology that had defined television from its early electronic development finally disappeared from most living rooms.
And notice the reversal. For much of television history, manufacturers tried to conceal the technology inside attractive furniture. With the flat panel, manufacturers increasingly tried to make everything except the screen just disappear.
Now, this right here brings us to one slightly confusing piece of terminology. People started buying LED televisions. Was that an entirely different display from LCD?
Usually, no. Most televisions marketed as LED TVs are actually LCD televisions using LEDs as their backlight. The liquid crystal layer still controls the image. The LEDs provide the illumination behind it.
Now, OLED is genuinely different. OLED stands for organic light emitting diode. Individual pixels generate their own light, so the display doesn't require a conventional backlight.
Which is why OLED sets can produce extremely deep blacks. A pixel that is supposed to be black can essentially turn itself off.
And today's manufacturers continue developing variations involving OLED, mini LED backlighting, quantum dots, and other technologies. But those are refinements of a much larger transformation. The bulky vacuum tube television became a thin electronic display.
Another important transformation happened inside the receiver. Traditional television was fundamentally an analog technology. Modern television is overwhelmingly digital. The United States completed the major transition of full power television stations from analog to digital broadcasting on June 12, 2009. That transition meant older analog only receivers needed additional equipment if they were to continue receiving over the air broadcasts.
Again, we're saving the history of broadcasting and signal delivery for another program. What's important for us today is what the transition did to the receiver. The television increasingly became a digital processor. Incoming information could be decoded, scaled, sharpened, stored temporarily, synchronized, and electronically manipulated before appearing on the screen.
In other words, the TV was becoming a specialized computer.
Yeah, and eventually we stopped pretending otherwise. Modern smart televisions contain processors, memory, operating systems, network connections, software applications, and increasingly sophisticated image processing systems.
Consider how dramatically that changes the definition of a television receiver. For most of the 20th century, the television's primary job was to receive an external television signal and reproduce its picture and sound. Today, the device may display material arriving through a tuner, an HDMI cable, a local network, an internet connection, a game console, a computer, or internal software.
And increasingly, people call all of that watching TV, even when the television isn't receiving the traditional television broadcast at all.
Which raises an interesting question. Is a modern television actually a television receiver? Or is it now a large computer monitor with speakers, networking, and a tuner attached?
Technologically, that distinction is becoming harder to defend.
There's something almost backward, I have to say, about this history. Early engineers struggled to make the picture larger.
Yes. The first experimental images were tiny. Then the picture tube became larger and larger. Cabinets became massive. Living rooms were arranged around the television.
But once flat panel technology arrived, the engineering goals changed. The picture was finally large enough. Now the objective became eliminating everything around it.
The cabinet disappeared. The knobs disappeared. The speaker grills largely disappeared. The deep picture tube disappeared. The screen border became narrower. And in some designs, even the television's visible wiring is being minimized or moved elsewhere.
So, after roughly a century of development, television design has moved to a surprisingly simple goal: make the television enormous and make the television itself almost invisible.
And that's an important distinction between a television receiver and television as a cultural institution. The machine has its own fascinating history.
In a later episode, we'll turn to the other half of the story, how television programming developed and how those programs actually made their way into people's homes.
Because once someone finally built the television set, someone had to figure out what to put on it.
So I want to thank you for tuning in and joining us today on Things You Don't Know. We will see you next time. We have some good stuff coming your way.
Yes, we sure do. Yes,
Bye for
and
now, folks.
be sure to leave a like, comment, and subscribe, and we will see you next time.